Good day guys, I am Alferos from ECE31 and I am here to present my experiment number 5 about 8-bit analog input. For the objectives of our experiment, to understand how the analog input works and to observe the characteristics of analog input. For our equipment and components, we need the PIC16 F18875, potentiometer, 220 ohms resistor, LED, breadboard, connecting wires, picket 3 or 4, and power supply. So, to give you a glimpse about analog input is a continuous input from the field to the PLC. Unlike digital signals, is not a constant voltage signal. It can vary depending on the field conditions. The commonly used analog signals are 4 to 20 milliamperes signal and 0 to 10 volts DC signal. Depending on the field conditions, the input signal can vary between 4 to 20 milliamps or 0 to 10 volts DC. For example, if you are monitoring a pressure of water flowing through a pipe using a pressure transmitter of range 0 to 10 bar, the transmitter will give a signal between 0 and 10 volts proportional to the pressure in the pipe. And what is a potentiometer? Like this. A potentiometer is a manually adjustable variable resistor with 3 terminals. 2 of the terminals are connected to the opposite ends of a resistive element, and the third terminal connects to a sliding contact called a wiper moving over the resistive element. The potentiometer essentially functions as a variable resistance divider. The resistive element can be seen as 2 resistors in series, the total potentiometer resistance, where the wiper position determines the resistance ratio of the first resistor to the second resistor. If a reference voltage is applied across the end terminals, the position of the wiper determines the output voltage of the potentiometer. So, our goal here is that we are going to use a potentiometer, and once we turn it to the right, our LED will light, and once we turn it to the left, of course our LED will be off. So let's start it. Our MPLAB X IDE, go to file, new project, standalone project. Let us enter our device, the PIC16 F18875. Next, our compiler, and our project name, which is EXP5. Finish. Tools, embedded, and the MPLAB code configurator. Select MCC Classic and finish. Just like before, we need to change this to PDIP40. Since our experiment deals with the ADC or analog to digital converter, we need ADC over here in the device resources under peripherals. Then let's add ADC. On the pin manager in the ANX, we need to click the 0, next 0, and over here in the GBIO, the fourth one on the port A. Going to the pin module, we just need to rename this as POT or potentiometer A0, and this one as T2 underscore LED, and just uncheck the analog under RA4. There. Under the system module, just like before, high frequency internal oscillator, 4 MHz, 4, and it is checked, low voltage programming enabled. And then we are going to go here on our ADCC and just check if the clock source is frequency oscillator, analog to digital clock. Clock is frequency oscillator over 2, right, VDD, VSS disabled, so nothing is to be changed here, and click generate. And then after generation complete, we need to go to projects, and under our experiment 5 header files, under that is the MCC generated files. All we need to do is click the adcc.age and pinmanager.age. And also our source files, we need our main.c file. Just scroll down and we will see our while there, but we need to go first on the ADCC and go to the line 240 to get the code. All we need to do is to highlight and copy the code and paste it on our while loop. We just need to fill the code and change our channel to pot_a0, and then let's put here the if greater than 512. Put d2 underscore led underscore, we need to set it high, and there. Okay, then put an else statement. Led again underscore, for this time we are going to set it low there, then just fix this. There you go. Our code is now finished. To explain the logic behind the code, the ADCC will produce a value from 0 to 1023, and we all know that the half of 1023 rounded off will be at 512, wherein if the value of the rotated potentiometer is 512 or more, then the LED will light up, but if the value rotated on the potentiometer is less than 512, then the LED will light off. And now let us build the code. Loading completed, and now before proceeding to the MPLAB X IPE, we need first to connect our picket. There you go. I have now connected again the pin 1 to terminal 1, pin 2 to terminal 11, pin 3 to terminal 12, pin 4 to terminal 40, and pin 5 to terminal 39. So in the MPLAB X IPE, our pickets was already recognized. We need to connect it. Just click OK. Our target device was not found, so in order to solve this, settings, advanced mode, you have to enter our default password microchip. Okay, and on advanced mode we will have additional options here. So going to power, we need to set our voltage level to 3.125, checking the power target circuit from picket 3, and going to operate, we need to browse our hex file. And our hex file, just open, and it's time to program after hex file loaded successfully. Okay, so programming complete, and now we can take off our cord and do the hardware. So following the diagram, I've constructed the circuit in my breadboard wherein this PIC 16F18875, so the pin 2 or terminal 2 was connected to the middle part or the middle terminal of the potentiometer. The first terminal of the potentiometer was then connected through the positive supply, and the last one, the third terminal of the potentiometer, was connected to the ground. And for the VDD and VSS, again, all VSS are connected going to the negative, and all VDDs are connected going to the positive. I have also inserted here the 5V supply, positive, negative, while on the 6 slot of the IC, we have connected there a 220 ohm resistor and then series with the LED light. So the LED light was then connected to the negative terminal of the board. So upon putting our source, we will expect that if we turn this potentiometer going to the right, the LED must light, but if we turn it going to the left, it must be turned off. So there you go. I have already inserted my power supply, so it is turned fully to the left. Now let's turn it to right. Turning to the right. There. As you can notice, it is already on the right. So it means that on the 1023, this is 512 or more, or 512 greater. And turning to the left, it is less than 512. So let us inspect or calibrate where is the middle part, somewhere here and there. So on here, this is somewhere the 512 value is. By the way, my potentiometer is valued at 500K. So let's take some time for it to be appreciated. Our experiment was successful. We have therefore configured or coded the code wherein if we turn this to the left, the LED must be turned off. If we turn this to the right, the LED must be on. So with the help of MPLAB X IDE, MPLAB X IPE, we can therefore say that this microchip is very helpful or very efficient to use for this type of applications. I hope you learned something. Thank you for watching and goodbye.